So for the last video today, we're going to look at average rates of change. Now, what you're being asked to do, if you're being asked for an average rate of change, is you're looking between 2 points on a graph. You're normally asked for the average rate of change on an interval. So you'll be given two x values. So for instance, if we were asked for the average rate of change on the interval x1 to x2, we'll be given those values. We're picking out this point here on the graph where x is x1 and this point here on the graph where x is x2, and we want to know the average rate of change of the function between that, and it's basically just a slope. So this is like the points here, x1, y1, and this is the point x1, x2, y2. But we're in function, so don't use y's, use f of x. So this is the point here, x1, function of x1, and the second point is x2, function of x2. So to look at that, all we want is the slope of the line between those 2 points. Let me get this stuff off my graph. That line, if you want to get all fancy about it, is actually called the secant line, but that's not a big deal. And think about how back in Algebra 1, how did you find the slope of a line between 2 points? You probably used that equation there. Do you remember it? Slope is change in y divided by change in x. So you get your second y value and subtract your first y value, and then you get your second x value and subtract your first x value. So that's what we're going to be doing here, but we're not going to call them y's. We're going to use function notation. So if you want to call it the secant line, you can get really fancy and say I'm looking at m sub sec, the slope of the secant line, and we're going to write exactly this, but instead of using y sub 2 minus y sub 1, y2 minus y1, we're going to use function notation. We're going to say function of x2 minus function of x1. So this is, I don't know if you can see that very well, it looks tiny on this screen. That's the equation. I'm going to write it out for you. So when we're doing these, what we're going to look for, our average rate of change is going to be our function of our second x minus our function of our first x divided by our second x value minus our first x value. And this is the equation you're going to use all the time whenever you see average rate of change. So let's try an example. This one's pretty simple. You wouldn't always be given a graph like that, but we have been given this interval here between x is -3 and x is -1. We've been given it algebraically because that's what we're going to work with, and this time we've been given a graph. We don't normally give you a graph, but this, as it's an example, will help. So when x is -3, we're looking at this point here, and when x is -1, we've got that point there. So you could do it just using points and pretend you're just in an Algebra 1 class. But I really want you to try and use the function notation because I want you to remember some of the rules you used to know with working with fractions. So let's start with our formula. Our formula is our function of our second, come on, why aren't you working? The function of our second x minus the function of our first x all over our second x minus our first x. So our second x is that -1, so we want the function of -1, and our second x is -1, and then we're going to subtract our function of our first x, subtract -3. So what will this become? Our function of -1, you could work it out separately here, but let's just write it all out in one great big ugly fraction. So this first part here is going to be -2 times -1 squared plus 4 times -1 plus 6. And then we are doing this subtraction here, and we are subtracting, I'm going to run out of space. We're subtracting this lot. So we're subtracting, because we're going to subtract the whole lot, you're going to need parentheses, and I'm going to have to write off at a funky angle. So we've got -2 times -3 squared, oh my goodness, plus 4 times negative 3 plus 6. Please don't write like that on a test. And then in the denominator, we've got minus 1 subtract negative 3. That's like negative 1 plus 3. Sorry, I'm having too much fun. Got to laugh at something in this life. So the denominator's easy. It's minus 1 plus 3, which is 2. Oh, I can do that math in my head. And let's look at the rest of it. So we've got negative 1 squared gives you 1. Minus 2 times 1 is minus 2. Plus 4 times minus 1 is minus 4. Plus 6. Then we've got that subtraction. Yeah. And the green bit that I've written off in a funky angle. Negative 3 squared is 9. Negative 2 times 9 is negative 18. Then we've got plus 4 times negative 3, so that's like subtract 12. Then we've got plus 6. Don't forget to distribute that negative to everything in those parentheses. And so what have we got here? Oh, we'll use blue. So this is minus 2, minus 4, plus 6. Oh, those all cancel each other out. That's nothing. Minus, minus, that's we've got 18, minus, minus, plus 12. Minus times a plus is minus. All over 2. We've got 30 minus 6. We've got 24 over 2. So our average rate of change on this one is 12. Which is positive, so does it look like it is increasing? Yay! And it's quite a steep line. Look how that graph, if you chose different intervals, say if you went between 1 and 2, that would probably be a fraction, I don't know, like a half. Minus a half because it's going down. Whereas if you're going there, that would be minus a much steeper value, a much bigger number, going negative. Let's try a harder one. Okay, this is considerably harder, so you try it on your own, then I'm going to go through it with you. So, pause your video, and I'm going through it in 5, 4, 3, 2, 1. Okay, so your final answer you should have reached was 3/5. If you managed to reach that without using a calculator, you've remembered how to work with fractions, and you're ready to go on. You don't have to watch the rest of this video. You can just go practice your homework. But many of you I know have been using a calculator for years to do fractions, and you've forgotten how to work with them. Now, there is an easy way of doing this that you could actually work out, shove negative 1 in here and work out a y value, shove 3 in here and work out a y value, and use this just finding the slope between 2 points. Like you would in Algebra 1, but that's not going to help you with when we start working with fractions later on in the year. We're going to not just have numbers in them, we're going to have words in them, and you really need to remember the rules of how to work with fractions. So let's go over some of those now. So we're being asked to find the average rate of change. So let's start off with a formula. Our function is g of x here, so So this here is our function of our second value minus the function of our first value, and it all has to be divided by our second x minus our first x. So substitute 3 in here, and you'd have 3 minus 1 over 3 plus 2. Then you're subtracting, put negative 1 in here. So you're subtracting one fraction from another. So that looks like that at this point. Now try and remember what you have to do to subtract fractions. Well, first of all, let's clean up the numerator and the denominator on those fractions. So 3 minus 1 is 2, 3 plus 2 is 5, minus 1 is minus 2, minus 1 plus 2 is 1, and the whole thing is over 4, so we end up with that at this point. Now, the second fraction you're subtracting there, you're subtracting a negative, so that's going to turn into plus. Do you remember that when you're adding or subtracting fractions, you need to use a common denominator? So what common denominator could I use here? Well, we can use the denominator of 5. If we multiply this fraction top and bottom by 5, we would get this. Negative 2 over 1 is the same as negative 10 over 5. And because we were subtracting it, that turned into plus. So add those two together, and you've got 2/5 plus 10/5 is 12/5, and it needs to be divided by 4. And remember, when you're dividing fractions, you want to turn the denominator into a fraction as well. And what you're going to do is you're going to keep the numerator the same, and then you're going to multiply. Instead of dividing, you're going to multiply by this reciprocal. So we're going to have 12/5 multiplied by 1/4. And to multiply fractions, you can multiply straight across the top, which would give you 12 over 20. But you know, that's a silly thing to do. Always look at your fractions first and think, can I reduce? You can reduce a factor in the numerator with a factor in the denominator. 12 is actually 4 times 3, and 12 is 4 times 3, 4 is 4 times 1. So we can cancel those by 4s and leave that with 3 there and 1 there. Now multiplying across the top, we've got 3 times 1 gives us 3. And across the bottom, 5 times 1 gives us 5. So our answer here is 3/5. So finishing off the question, the average rate of change over the interval -1 to 3 is 3/5. And yes, that is 0.6, but in pre-calculus, calculus, we very, very rarely, we don't want you to give us decimals. We want you to always, if possible, give us simplified fractions for your answers. This is a positive number. It's not negative 3/5, it's positive 3/5. So that's telling us that on this interval, on average, the function is increasing. Okay, that will do for the lesson today. And go try your homework.